Hello, pre-calculus class. Okay, this is Mr. Bryce, and we are on page 329. We're doing number 58. Find the cotangent of 30 degrees. Okay, so here we go. That is 30 degrees. The first thing that we know is no calculator. Bummer. Okay, the second thing that we know is that we only know the answers from the unit circle of cosine and sine. So somehow we have to have cotangent in a sine and cosine format. So let me see, cotangent. Cotangent is 1 over tangent. And 1 over tangent is 1 over sine theta over cosine theta. Well, wait a minute. Okay, so that is really confusing. Whenever you have a nested fraction like that, just take the reciprocal of the denominator and multiply it by the numerator. The numerator was 1. Okay, so we're going to multiply that by the reciprocal, cosine theta over sine theta. Oh, that's pretty easy. So the cotangent of 30 degrees equals the cosine of 30 degrees over the sine of 30 degrees. Okay, now I'm going to take a look at my unit circle and see that that's about a 30-degree angle. And the cosine, remember the cosine is the x value. So the x value happens to be at its largest at that point, which is square root of 3 over 2. Square root of 3 over 2 divided by the sine happens to be the smallest value. Now, if you don't remember that they order in square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, oh, that's just 1/2, okay? So the sine is the y value, and that's the shortest y value, so that's 1/2. Okay, again, I just said nested fractions. When we have nested fractions, the square root of 3 over 2 times multiplied by the reciprocal, 2 over 1. What reciprocal? The reciprocal of the denominator. So the 2's cancel, and we get just square root of 3. So the cotangent of 30 degrees is square root of 3. Key point here. Get everything in terms of sine and cosine. So I just did a quick Google for trig identities, and here it says sine, cosine, and tangent. And what does it look like? What we have is we have a C, and then if this is our angle, so it's the triangle looks like that because it's going to be opposite over hypotenuse, okay? And then adjacent over hypotenuse. And then we're going to have opposite over adjacent. Those are sine, cosine, and tangent. Well, we know that. We've known that since 4th grade. So what are we dealing with here? Cosecant, secant, and cotangent. Remember that cosecant is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tan. You have to know that. You have to know that. Are you going to have it on your reference table? Well, you might, but not for Friday's quiz, you aren't. Okay. So that brings us to the secant of 30 degrees. Number 59. So we know that the secant of 30 degrees is 1 over cosine. So the secant of 30 degrees equals 1 over cosine of 30 degrees. Really? It's really going to be that easy? Yes, it's really going to be that easy. So what you do is you find out the cosine of 30 degrees. Square root of 3 over 2. That's the x value. Okay. Now, all you do is multiply by the reciprocal of the denominator. Okay. Okay, well, that looks pretty easy. It's 2 over the square root of 3. But the back of the book gave me a different answer. That's because you have to rationalize the denominator. Square root of 3 times square root of 3 is just 3. And 2 times the square root of 3 is 2 square root of 3. Let's look at another problem. Number 65, the cotangent of theta equals the square root of 3 over 3. Okay, remember that the cotangent is 1 over tan, and tangent is sine over cosine. And when we have a nested fraction like this, we want to multiply by the reciprocal, and it's fantastic that that's a 1. So we all know that this is cosine theta over sine theta. Okay, now we go back here and say that it's square root of 3 over 3. Okay, square root of 3 over 3. The cosine is square root of 3. The sine is 3. Sine is the y value, and cosine is the x value, alphabetical order. Now, let's see. We're trying to find the angle. We're trying to find that angle. Remember, we only know sines and cosines. Well, we have to know the hypotenuse for a sine and cosine problem. We want to get everything in the terms of sine and cosine. We have things in the term of sine and cosine, but now we still have to find that angle. We have the x value, we have the y value. That is a right angle right there. So that's why I asked if you know that leg squared plus leg squared equals the hypotenuse squared. Square root of 3 squared plus 3 squared equals the hypotenuse squared. Square root of 3 squared is 3. Square root of 3 is 9. And that equals h squared. So this is 12. And our, I know I'm writing fast, talking fast. So the square root of 12 is h. Well, you should know that the square root of 12 is really 2 square root of 3. Because you look for perfect squares hiding inside 12. 4 times 3 is 12. We have to know that. We have to know that. So that's h. That's not our answer. That's just h. So the hypotenuse is 2 square root of 3. Now, I'm going to get a little bit of extra room here. Erase, 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 and gone. Okay. So now, this is still the same angle. Did the angle change at all just because I found out how long that side was? Of course not. It's still the same angle. So the cotangent of theta, you know, that angle right there. Now, we want to find out how big theta is, right? Number 65, we want to find out exactly how big theta is. Find the angle. Find the measure of the acute angle. So we want to find out how big that angle is. Well, now that I know what the hypotenuse is, why don't I just go with sine? Sine of theta, still the same triangle. Oliver has opposite over hypotenuse. Oh, that sucks. Opposite over hypotenuse. Hey, I'm just thinking ahead. It's a good thing that I went in this direction, because now I say, why don't I do cosine of theta? You made me erase. Yes, of course I made you erase. Cosine theta. A hat. Why? Because they both have square roots of 3 in them, and I know I can simplify it easier. Okay? So the cosine of theta equals adjacent square root of 3 over hypotenuse, 2 square root of 3. Do you see they cancel? The answer is 1/2. The crowd goes wild. Okay, so we had to get everything in terms of sine and cosine. Get everything in terms of sine and cosine. Well, wait a minute. That means we also have to find the hypotenuse when we're trying to find the measure of an angle. Okay, this is all just using problem-solving techniques. Don't worry if you got to go down the wrong road. Just back up and try different roads. See, I erased. It didn't kill me. I hope. I'm okay. By the way, I didn't answer the question. The question said to find the angle measure. So now that we know, this is going to be for the next one. Now that we know that the cosine of theta equals 1/2, we take a look at our unit circle and say, where's the cosine equaling to 1/2? Cosine equaling to 1/2, remember cosine is our x value and 1/2 is our smallest one. So there it is right there. It must be our second to largest angle. Some of you might think it's our largest angle. So theta equals 60 degrees. I say second largest because 90 degrees is the largest. So the final answer is 60 degrees because the cosine of theta equals 1/2. Now let's take a look at secant equaling 2. Mr. Bryce, bummer. That's supposed to be secant of theta equaling 2. Okay, so I pulled this up because, again, secant is 1 over cosine. 1 over cosine equals 2 over 1. Okay, 1 over cosine of theta equals 2, or 2 over 1. Well, what in the world do we do here? Oh, I know. You might think that you want to, no, that's the long way home. We don't want to take the long way home. If we have 1 over cosine or 1 over sine, why don't we just reciprocate the first fraction? And if we do whatever we do to the left, we have to do to the right. Oh, so the cosine of theta is 1/2. Oh, are you kidding me? I'm not kidding you. This is also 60 degrees. So secant theta equaling 2, what is theta? Theta is 60 degrees. Cool. Same triangle, same angle. Okay, so it says do number 75 without a calculator. Well, the sine of 45 degrees is very easy. The square root of 2 over 2. Now remember, the cotangent of 60 degrees is the same as the 1 over tangent of theta, and 1 over tangent of theta is 1 over sine theta cosine theta, and that's just cosine of 60 over sine of 60. So, what do you have to write on your test? Right up to there. That's showing your work. Okay, now, what's the cosine of 60 degrees? It's 1/2. What's the sine of 60 degrees? Square root of 3 over 2. And the thing that I love about these are the fact that we're going to multiply by the reciprocal. 1/2 times 2 over square root of 3. And those 2's will always cancel out. So we have 1 over square root of 3. Well, hey, I don't know what that is, but I do know that when I rationalize it, it's the square root of 3 over 3. Because I multiplied the numerator by square root of 3 and the denominator by square root of 3. So we have square root of 3 over 3, comparing it with the square root of 2 over 2. Ooh! Let me get a little bit more room. And this is where we get into trouble for using electronic devices because, I mean, I know that the square root of 2 over 2 is 7071, and I know that the square root of 3 over 3 is 0.5774. I mean, because I've been using trig tables, well, since I was younger than you. So I know that the sine of 45 degrees is greater than the cotangent of 60 degrees. Let's take a look at another example, see if we have to use calculators for these. So let's take a look at number 77, the cosine of 30 degrees. Okay, we know what that one is. Cosine of 30 is square root of 3 over 2. Now the cosecant is 1 over sine of 45. Okay, hopefully I can deal with this. Uh, the sine of 45 degrees is square root of 2 over 2. So the square root of 2 over 2 is the sine of 45 degrees. That is going to be on the denominator of our fraction. Remember, we want to multiply by the reciprocal, so we're going to compare square root of 3 over 2 with multiplying by the reciprocal is 2 over square root of 2. Ink, ink. So, sorry, didn't want to do that. So I just rationalized the left-hand side, and I'm comparing these. That's why I didn't want to cross those out. So now, they have a common denominator. I have to compare the square root of 3 with 2 square roots of 2 without a calculator. Okay, I got it. I was thinking for a while and thinking for a while. Well, here, why don't we do this? This is the square root of 3. This is really the square root of 4 times the square root of 2. I just squared the 2 and put it inside the square root symbol. So the square root of 3, compare it with that. The square root of 3, we're comparing with 4 times 2, the square root of 8. Which one's bigger, 3 or 8? Square root of 8 is bigger. So you just turn it into an improper radical, and there you go. So if you blinked, you may have missed it. What I did was I turned them into a single radical on either side, not a mixed number fraction. You know, it's an improper radical. So if everything's underneath the radical sign, I just have to compare the numbers under the radical, and whichever number under the radical is larger is going to be the larger simplified radical. Okay, now I'm going to go on to page 233 right now. And we're going to talk about changing degrees into radians and radians into degrees. So the first example there is giving us an answer that we already know, 120 degrees. How many radians is that? It's 2 pi over 3. But let's just figure out, we know the answer. We're just going to go through the bookwork. Okay, so I am going to multiply 120 by 1. Really? I'm going to multiply 120 by 1. What use is that? Well, 120 degrees times 1. Well, 120 degrees is 120 times, instead of saying 1, I am going to say pi. Well, pi is the same as 180 degrees. So 1 is pi divided by 180. I could have used any of these. I could have used, instead of using pi over 180, I could have used pi over 2 over 90. Well, that gives us complex fractions, and we really don't want to have a fraction nested inside a fraction. So that's why I used pi over 180, or you could have used 2 pi over 360 if you felt like it. I see that often in books too. Anyway, the point is I am just multiplying it by 1. 120 degrees is 120 times 1, and 1 is just pi over 180. Why did I use 180 degrees? Because the degrees, they cancel out. So I have 120 pi over 180, and these are radians. Mr. Bryce, you said the answer was 2/3. Oh, those cancel out. They're both even. And guess what? 6 goes into 12 twice, and 6 goes into 18 3 times. So we converted degrees into radians by multiplying the degrees by pi over 180. I'm about to erase it, and it's gone. So let's say I have something in radians and I want to turn it into degrees. Well, why don't I just divide by pi over 180? I multiplied by pi over 180 to get it from degrees into radians. Now I'm going from radians into degrees, so I just divide. Well, that doesn't look like what the book is doing. Oh, yes, it does, because to divide, you multiply by its reciprocal. The pi's cancel. Can I simplify this? 90 over 1, negative 270 degrees. So if you just remember that you're multiplying or dividing by pi over 180, or you can remember to change from radians into degrees, we obviously need the pi's on opposite sides of the fraction bar, one on the numerator, one on the denominator, to have them cancel out. Pause. Let's turn to page 235 because I really like finding the measure of an arc. Okay, now we've been talking about radians. What's so special about radians? Why don't we just keep things in degrees? Well, degrees came from a misconception. Does anyone know what that misconception is? Well, I'm not going to tell you. You're going to tell me tomorrow. Okay, degrees came from a misconception. Something was totally off base and wrong. So that's why I like radians, because radian is the radius. Okay, so what we have here is on page 235, B, 60 degrees, with the radius equaling 2 inches. Okay, the first thing that you have to do is exchange 60 degrees into radians. So 60 degrees times pi over 180. How do I know 180 is in the denominator? Because the degrees have to cancel. It's just a way to remember, just common sense. Okay, now it happens to be that 60 goes into 180 3 times, so it's pi over 3 radians. That's how long it is compared to the radius. Okay, 60 degrees is pi over 3 radius. Now, if the radius, or radii, is 2 inches or 2 feet, I think that this specifically says 2. Okay, so let's just say it's 2 astronomical units. So if the radii is 2, then all we have to do is multiply it by the angle measure in radians. So it's 2 pi over 3. And that's how long the arc length is. What? Why in the world do I want to know an arc length? Well, notice I said 2 astronomical units. Okay, so here I'm going off on a tangent. No pun intended. But we have a 60-degree angle. Okay, that's really not 60 degrees. We have a 60-degree angle, and we want to know how long this arc length is. Well, I said that this was 2 astronomical units, 2 AU. And so we know from our previous calculations down here that it is 2 pi over 3. This is 2 pi over 3 astronomical units. If we know the velocity of a planet moving in orbit around the sun, and we launch our satellite when the planet going around the sun is right here, we can determine the angle so that we actually land on that planet. So this is fairly important and simple mathematics. At this time, the substitute teacher is going to tell you what your homework is. You should have about probably 12 minutes to do it, maybe 10 minutes to do it. Have fun. I am down the hall in a meeting right now, and hopefully the meeting will be over before 3 o'clock, but I highly doubt it. This is the last meeting. Keep our fingers crossed. See you later.